Hello and welcome to another exciting session on time value of money. So, whether in business, you are a homeowner, you're financing your car, you're studying, this session will definitely assist you because you're going to cover amortization. So, with regards to going through this session, after you've completed this session, we're expecting you to have obtained an understanding on the following. Calculate the future value of an amount invested today. Calculate the time it takes an investment to grow. Calculate the interest rate. Calculate the annual payments of a future value. The effect of compounding and amortization. So, to apply the principles of time value of money on determining a future value, we are going to look at a question here whereby Charlene deposited $100,000 in an investment generating interest of 8% per year. So, how much would the investment be worth after 2 years? So, with regards to this, our 100,000 here will be a present value because it's a once off investment. Then, interest will be 8% compounded annually, which is our interest. Then, our N will be 2. So our inputs will be the following, like that, will be presented like that. So to input that into our financial calculator, we need to first clear our memory. Then we punch in 100,000 is the PV, then 2 is our N, then 8 is our interest, then we compute the future value. So there 116,640. So the investment will be worth that much, all right, after investing for 2 years. So your answer is given as a negative because we input the PV as a positive, right? Doesn't mean that it's a negative cash flow or anything there, right? Then we come to the other part, which is calculating the investment period. So they want to see how long it takes an investment to grow. So here we are also apply the principle by doing a question. So in our question here, how long does it take for Marco's investment of 200,000 to grow to 450,000 at an interest rate of 8%? So we are looking at the time it's going to take. So in here, 200,000 is our PV because it's a once-off investment. Then our FV will be 450,000. Then the interest is 8%, which is also compounded annually. So we want to compute the N. So our inputs there will be presented in the calculator as a negative of 200,000, then 450, and as your FV, then I is 8. So now, with regards to that, our calculator, for you to calculate the N, you need to input your 200,000 as a negative, which is your PV, you need to make it a negative, or you can make your FV as a negative, right? So one of these two needs to be a negative for it for your calculator to be able to calculate. If you don't do that, your calculator will show no solution. So here we punch in the 200,000 as a negative, then PV, then 450,000 as a positive, FV, then then I of 8%, then we compute the N. So it means it takes us 10 years. It will take Marco 10,54 years for the investment to grow from 200,000 to 450,000, right? Then we come to calculating the interest, right? So there sometimes you want to know how much interest will you need to be generating for your investment to grow to a desired amount. So in here we have an example here whereby Rua wants to invest, right? So Rua wants an investment that will allow her investment amount of 5,000 to grow to 10,000 over a 3-year period. So at what interest rate should the investment be earning for it to grow to that desired amount? So again there, our inputs will be the 5,000 is a present value, it's a once-off investment, then he wants to the amount to grow to 10,000, which is the future value, then over a period of 3 years, right? Then we want to compute the I, right? So again, either your PV or your FV needs to be a negative for the calculator to compute for you. So in our case here, we have our 5,000 as a negative there, cash flow, because she's actually investing. Then it's PV. Then 10,000 is the future value. Then 3 is your N. Then we compute the I. So it means that for the investment to grow from 5,000 to 10,000 over a 3-year period, it needs to be invested at 25.99% for it to grow like that, right? Then we come to annuities, right? So in here, we want to determine if you want to save for a desired be it investment to see how much will it grow. You want to buy a house, like in our example here, Mike wants to buy a house in 5 years time, which is going to be worth 500,000 at that time, and now he wants to know how much should he be depositing in terms of savings each year at interest rate of 10%, so that the money can grow to be 500,000 in 5 years time, so that he can be able to buy his desired asset. So our inputs here would then be 500,000 is the future value, 5 is the N, which is the period it takes for the savings to be made, then the interest rate that is going to be investing at is the 10% there. So again, 10% compounded yearly. So now, with regards to our inputs, we're gonna have our 500,000 as the FV, right? Future value, then 5 as our N, then 10 as our I, then we compute the payment. So yearly, Mike needs to be depositing 81,898.74, such that by the end of 5 years, the amount would have grown to be the 500,000 there. All right. Then we also want to look at the effect of compounding, whereby the interest is not only compounded once in a year, but it's actually being compounded more than once. So normally that's what happens whenever we deposit our money in the bank. You deposit your money in the bank every month, it earns interest, and in the following month, that interest you generated in the first month also earns interest again in the following month. So your capital and your interest will earn interest in the following month. So with regards to this, we're gonna apply the concept via an example here, whereby Sharon wants to deposit a amount once-off amount of 10,000 into your bank account that will be earning interest of 10,000 compounded monthly. How much would the amount be in 5 years' time? So with regards to this now, when you're going to input our amounts here, which is the 10,000, which is the present value, and the interest. But now with regards to the interest, since it's being compounded monthly, we need to calculate the effective interest rate first of this 10%, right? Such that we will be able to then use that effective interest rate for the purposes of calculating what the future value will be in 5 years' time. So that step of effective interest rate for that 10% compounded monthly, we need to first set our calculator to 12 periods in a year, right? Then we take the 10%, which is a nominal interest rate, then we convert it into an effective interest rate there, right? So now that we've gotten our effective interest rate, we convert our calculator back to 1 period per year. So we now say that 10,000 that she's investing there, it will be a present value, then 5 is the N, then we take the 10 0.47 interest, then we compute the future value. So it means now that 10,000 invested over a 5-year period, earning interest of 10% compounded monthly, which becomes 10.47 effective interest, you'll be able to earn 16,452. That's what will be the amount what you do that 10,000 will be worth after 5 years. Right, so now we want to go to the concept of amortization. So for those who are studying, this definitely is the tricky part. You get your questions where they want you to either calculate your balance, your interest, or the amount that is being paid so far towards the principal component. So if you are someone who has bought a house or you're financing a car, this will definitely assist you to determine how much is the outstanding balance after making certain payments, or how much have you paid so far towards interest, or how much have you actually paid towards the principal debt itself. So with regards to that, we're going to be applying that concept via an example here. So our example here, Abigail wants to buy a house worth 200,000 on a mortgage bond of 20 years, right? How much would the monthly installments be at an interest rate of 8% compounded monthly, right? Then after that, we also want to determine what will be the outstanding balance after paying for that house for 2 years. Then also the other part is what is the total interest paid for the first 2 years, right? So our inputs here, the 200,000 would be a PV, right? Because that's what the house is currently worth. Then over a 20-year period, your number of payments there, since they'll be monthly, you're gonna make 12 payments times 12. 12 payments times 20 for those 20 years because it's monthly payments. Then your interest rate, it needs to also be at a effective interest rate. However, the impact of effective interest rate there, considering that the interest will be compounded monthly, we are going to apply whereby we divide the interest by the number of compoundings in a year. Then we also have our n being multiplied by the number of payments that we're also going to make in a year. So in there, we are going to have our inputs as follows. So our inputs would then be the PV, the 200,000, then your N will be 20 times 12, then your I will be 8 divided by 12, then you compute our payment. So to do that, we're going to input that in our financial calculator, where you're going to say 200,000, which is our PV, then 20 times 12 is our N, then we have our 8 interest divided by 12, then we get our interest, right? Then we compute the payment. So the monthly payment would then be $1,672.88 a month. So that's what they should be paying towards the house. So when you're doing amortization, you do not clear your memory because you want to use the information that your calculator is calculated for you to determine what is the remaining balance, what is the principal amount, or what is the interest component. So after 2 years, right, considering now that our total period here, we said it was 20 times 12, which was a total of 240 periods for that 20-year period. So now to calculate the balance after 2 years, right, we want to, considering that the other part C wants to determine the total interest for the period 1 until period 24, because we have 2 years, so 12 months in first year, another 12 months in second year. So it becomes 24 periods. So to input that into our calculator, we punch in 1 to do amortization. So 1, then input. So you're telling your calculator to start amortizing from period 1, then until period 24, right? Then you punch in shift, then amort. So your calculator is now period 1 to 24. That's when it's the period it's amortizing. So then you punch in equals, right? So the first equals is showing us that for that period, how much money is actually for that 24 month period, how much of your payments have gone towards reducing the principal debt. So it's only 8,800 that has gone towards that. Then total interest you've paid for that period, it's an amount of 31,343, right? Then in terms of your remaining balance, it's your 191, 194. So for our part B, that's our balance there, 191,194 that you've paid thus far. Then our interest for part C is just the 31,343. So if you look at it there, you will notice that a lot of the amount that this person has contributed has gone, has paid towards the debt has gone mostly to interest. Was 31,000 has gone to interest, whereas the only amount that has gone towards reducing the principal debt is only 8,800. So that's what happens, that to say, yes, they will tell you interest is 8%, but when you look at how much you've paid, if you take your total payments of 1,672, multiply them by 24, it will be quite a lot of money that you have actually paid, right? But the only amount that has just gone towards reducing your principal debt would have only been an 8,000, whereas the other 31 has gone towards interest. So your total payments basically is around almost 40,000 there, because you've paid 31,000 towards interest, another 8 towards principal debt. So you can see your principal debt is reduced by just a little, but a lot has gone towards interest. So the 8% is not necessarily how much in terms of proportion of your payment you are saying is going towards interest. Rather, it will be way more, because if you look at the percentage of amount going to interest compared to the one going to your principal debt, surely it's way more than that. So it's almost like a 25% to a 75% there, compared to the interest. So yeah, this is how your amortization you go about it. So I hope this session was quite helpful to you, whether you are in studies, or you are someone who is financing their house or cars. This should definitely assist. Thank you, and I will see you in the next session. Okay, bye.